Welcome to the Advantech Technical Training. In this topic we will talk about the serial communication concept. The outline of this presentation will go through these 7 topics. First we will talk about the serial communication concept and data format. Second, explain the communication between the PC and external devices. Third, introduce the transmission mode in serial communication. Fourth, talk about popular industrial serial communication standards, and finally, CAN bus concept and comparison table with other standards. Now, we will explain about the concept and formats in the serial communication. How is established a communication process and what are its elements? Communication is the process of sending and receiving the data over a communication channel. Basically, 2 parties are involved in this process. One is the signal source, that is the sender, and the other is the receiver or destination. The interface is the physical layer or channel through the data travels. The protocol is the language that the 2 parties use to understand to each other. Making an analogy with the industrial world, in this scenario we have an example. There is a PLC as an slave and the computer as a master. The interface they use can be either by serial port or Ethernet port, and the protocol or language to communicate will be Modbus, Profinet, EtherCAT, etc. A communication protocol is a system of rules that allow 2 or more parties to transmit information via any channel. The protocol define what, how, and when the 2 parties can communicate. What is the serial communication? The serial communication is the transmission of data between 2 ports, or point-to-point. The most important feature of serial communication is that the port sends and receives only 1 bit at the time. This image shows how is a typical digital signal in communication. According to it, we can see the digital signal as 1000101011. This is called a square wave, or we can call pulse signal. What is the difference between a serial communication and parallel communication? To transmit the data it can be used either serial or parallel communication. In the serial communication or asynchronous communication, the user can start to send data at any time based on his application need. The application doesn't need a clock signal to send data, and it could support long range for data transfer. The parallel communication or synchronous communication is when the ports will send and receive more than 1 data simultaneously. As the animation, you can see the 8 bits data will transfer of data at the same time. It needs to use a clock signal to make sure the sender and receiver are synchronized and to avoid possible missing data. Now, we will explain about this rules and formats in the serial communication. In this graph we can check a simplified schematic of the transmission of data in the serial communication. In the upper field we can find the representation of the physical signal that can be voltage. There will be 2 states for this voltage, either high state or low state. The high voltage means a range from 2 to 5 volts, and for low voltage from 0 to 0.8 volts. So making a correspondence for digital signal, in the bottom of the schematic, when the voltage is in high the digital signal will be 1. And on the other hand, when the voltage is in low the digital signal will be 0. Normally the serial packet in the serial communication is composed by 9 to 12 bits. In the serial communication, both the sender and the receiver must have the same format data setting for a successful communication. The basic format for the serial communication should include: start bit is the first bit to inform to the receiver when the packet starts. Then the receiver can start to decipher the packet. Later we have the data by itself, that is the mean message, usually from 7 to 8 bits. This will depend on the transmission standard between devices. Parity is used to check if the data has successfully being sent and received and for error checking. And at the end of the packet is the stop bit, which will inform to the receiver that the packet has been completed. The baud rate in serial communication is used to describe the speed of transmission of how many kilobits will be transferred in 1 second. Communication between PC and external devices. Communication interface between a computer and the external devices. In serial communication, there are some interfaces for a computer be able to communicate with external devices, so every interface will have different applications. Common interface are VGA, USB, LAN, PS2, GPIO, etc. In most of industrial applications it is used the serial port with 9 pins. This allows the communication between the computer and the serial devices such as PLC, RTU, HMI, printers, digital scale, barcode, or any device that supports serial communication. But all of these devices follow the same principle, that the data will go through the cables and allow the exchange of data from the sender and the receiver. Onboard and extension interfaces. In industrial computers, to install a serial port there are 2 types. One is onboard serial port and the other is extension serial port. Onboard serial ports are built-in COM ports of the computer and can be modified in the BIOS under the Super I/O section. Above are the images for AMI and Award BIOS Super I/O setting pages. When the hardware is running under Windows, the operating system includes original COM port drivers, which mean it is not necessary to install additional drivers. The extension COM port cards are also used to increase the number of COM ports in a computer. Extension serial interface has multi-type and flexibility. It can insert into an industrial PC or normal PC. There are different interface of serial extension card: PCI, PCI Express, PC104, PCI104, or USB. These serial extension cards require the installation of drivers and the use of additional cable. How to find the available COM ports in the computer. Comparing with onboard serial port, extension serial port is controlled by its own hardware and every vendor will develop its own driver. Above you can see the difference on the device manager of a computer. On one hand we can see the driver of the built-in COM port number 2. And on the other hand there is a Advantech driver for our card PCI 1612 that enables the COM ports 3 to 6. There are 3 transmission modes in computer networks. In simplex channel the data flows always in one way. It is not often used because it is not possible to send back error or control signals to the transmit end. The examples of simplex are broadcasting or radio. A half-duplex channel can send and receive the data but not at the same time. Examples of half-duplex are talkback radio or RS-485. In full duplex communication the data can travel in both directions simultaneously. The examples of full duplex are the telephone, RS-232 or RS-422. In the industrial applications 3 interfaces standards widely spread. RS-232, RS-422, and RS-485. For them, it is usually employed the DB9 connector with 9 pins, which can be found in the industrial computers under the name of serial port. The first configuration of RS-232 uses 8 of the 9 pins for the transmission of the data. For the RS-422 it uses 5 pins. And for RS-485 only uses 3 pins for the transmission, which represents an advantage over the other configurations during the installation of the equipment. RS-232 is an interface standard used for serial communication, it is used for connecting computer and its peripheral devices to allow serial data exchange between them. This slide shows the pin assignment for RS-232. Usually the RS-232 connector is a DB9 and DB25 types. DB9 means use 9 pins signal interface and the DB25 means use 25 pins. Every pin has been defined its function. Nowadays, DB25 is very few to use, most connectors use DB9. The features of RS-232 standard are: it supports full duplex operation. The data can travel in both directions simultaneously, but it only can handle the communication between two devices. It provides a low transmission speed up to 115.2 kbps with a short transmission distance up to 15 meters. Over this distance it will become hard to distinguish if the signal high or low. It does not have noise rejection. Since it uses single-ended wiring, the ground is always connected, so it may be attracted by noise and decay the signal a long distance. For RS-485 standard, it supports half-duplex operation which can send and receive data, but not at the same time. It has noise rejection and cross-wire to reduce the electromagnetic interference. Additionally, it supports long transmission distance up to 1,200 meters at a high transmission speed up to 10 megabits per second. Finally, it saves the wiring cost because only uses 3 wires for the data transmission. Applications for RS-485. There is a wide variety of devices employing RS-485 standard in the industrial environment, such as POS, in the control of automatic systems and in the sensing field. This is because the benefits of using this standard. How many devices can be interconnected in the same network? Every configuration has a limited work. Every configuration has a limited number of devices that can be interconnected. For example, for RS-232 standard only can be connected one device to one host. So in the industrial environment with a lot of machines this may be inefficient. For RS-422 it can be connected up to 10 devices to a host. And the RS-485 is the most popular configuration because it can be connected 32 devices in a network. Now, we will discuss about the advantages of RS-485 over RS-232. This table is a summary of the comparison of these 3 standard interfaces. RS-232 can connect only one device to the host along a distance of 15 meters with a maximum data rate of 115.2 kilobit per second. Alike, with RS-485 can be connected 32 devices to the host along 1,200 meters with a maximum data rate of 35 megabit per second. This is a diagram is for your reference that can be useful in solving problems related to serial communication COM ports. It starts suggesting you to check the COM port mode settings, then check the right pin assignment, finally test the loop back. Now, let's going to talk about another serial communication standard called CAN bus. What is CAN bus? The CAN bus stands for Controller Area Network. The first idea of CAN bus came from the engineers of Bosch searching for a protocol for connecting multiple devices in automobiles that also can save money on wiring. Basically, CAN bus is a robust vehicle bus standard that was designed to allow microcontrollers and devices to communicate with each other in real time without the need of a host computer. What are some real applications of CAN bus? Nowadays, CAN bus is one of the 5 protocols used in the diagnostics of vehicle. However, the CAN bus protocol can be used not only for automotive industry but also it can be found in factory automation, machine control, medical equipment, and more. How was the topology before CAN appear? The development of CAN began when more and more electronic devices were implemented into modern motor vehicles such as engine management systems, active suspension, ABS, gear control, airbag, etc. All this means more safety, comfort, and reduction of fuel and gas emissions, but this also represents the connection of all of these devices to a master host. Alike, how is the topology with CAN bus? As a solution, CAN bus proposed a protocol that allows the connection of the control systems via a serial common bus. So actually, it replaced the traditional point-to-point wiring that consumed a lot of time and didn't offer reliability. How is the mechanism of message transmission in CAN bus? CAN is a broadcast type of bus where all the nodes can hear all transmissions. There is no way to send a message to just a specific node. The CAN hardware, however, provides local filtering so that each node may decide react only to the messages that are relevant to them. Example of message transmission in CAN bus. In this scenario, the whole system is composed by some small modules that contain the sensors. In the internal circuit of the car, the ECU sends a message that requests what is the block's temperature. All the modules can receive that message. The modules using filters will check if the information is relevant and will give back a response. Finally, the ECU will take the information of the temperature and display the information on the console. The same information can be displayed in an external panel employing a CAN bus PCI card that will be the interface between the ECU and the exterior. CAN bus architecture. The physical layer for CAN consists of three signals: CAN high, CAN low and ground. These are shared by all nodes on the network. The physical value of the signal is resolved by the differential voltage between CAN high and CAN low signal. When the difference is maximum larger than 0.9, it means a logic level 0, and when the difference is minimum below 0.5 means a logic level 1. The CAN_high and CAN_low signals provide a differential signal and allow collision detection. Now, how does this help? With this simple technique you can ensure high susceptibility to noise, because noise will affect both wires at the same time and hence the difference would be the same. This enables high baud rate up to 1 Mbps with higher redundancy. Now, we will explain about the data format in the CAN bus standard. The format in CAN bus packet consists of 5 main fields. In the arbitration field, the first bit marks the start of a message. The arbitration field helps to assign a priority among the devices. This is necessary because sometimes several messages try to access the bus at the same time. Only one device can transmit at the time and the other devices will be in listening mode. The identifier is not defined by the CAN protocol. It is specified during system design and cannot be changed dynamically. Next, the control field contains the number of bytes of data being transmitted. The CRC and ACK are used for transmission error detection. If one or more errors are detected, the transmission is aborted, which prevents other stations from accepting the message. Finally, the end of frame marks the end of the CAN frame message. Now, let's going to talk about the difference between the devices that use these two standards. Comparison table of CAN bus and RS-485. Making a comparison between the two standards, we can say that the CAN bus has a better immunity for noise, supports higher speed of transmission of data along 5 km. Additionally, it provides a error detection provoked by channel's noise and offers the multiple master mode. as backward CAN bus can only support maximum of 64 devices, unlike RS-485 that can support up to 254 devices with the help of repeaters. Within the serial communication solution that Advantech offers, here, we have some examples. In the left-hand side, we have the devices for sensing and control. They support the RS-485 standard of such as remote I/O, smart meter, device server, etc. In the right-hand side, are presented the products that support a CAN bus standard such as vehicle computers, CAN bus cards, and modules. Thanks for watching this training video. You are welcome to keep watching the next one.